Hello everyone, this is Jeremy Derteen with the NaturaConnect project. I'm here to present a short exercise on how to use least cost path plugin that is available in QGIS. Now this plugin is especially helpful for more regional assessments, and particularly because it can only work with points specifically and just one start point with multiple endpoints. Before we get started though, it's important that we need to load in the plugin itself. So we go up to plugins and hit manage and install plugins. So if we go to all, and then we just search for least cost path, and you can see it's already clicked for me because I've already loaded it, of course. And then we can just click on that, and then you should say install if you haven't installed it already. Another plugin that I like to use for the base maps, since I'll be jumping between a few different base maps, I thought it would be good for everyone, and maybe you already use a different type, but if not, I typically use NextGIS Quick Map Services just because they have a pretty nice library of base maps that are pretty easy and fast. So once that is installed, they should appear in your installed section of plugins, as long as the search bar is empty. So those two are clicked on for me, and so I'll close this. So I'm providing some data, just example data that we can play with and work with. Specifically looking at Central Balkans from Bosnia and Herzegovina down to Northern Macedonia and across Serbia, Kosovo, and Albania, and a small portion of Croatia. So these data, if we open up the attribute table, just have a basic ID, the World Database Protected Areas ID, three character country code, and then the total area in kilometers squared, in square kilometers. So as I said, the least cost path plugin requires the use of just points. It doesn't have a ability to use these polygons, so we first need to create centroids. So I've created centroids. To create your own centroids, you can go up to the processing toolbox and search for centroids. The one I was using is underneath the vector geometry. If you don't have this processing toolbox, or if that's gone somewhere, you can just go up to processing in the top and hit toolbox. So you can click on centroids. This is our polygon layer. And then you can create either a temporary layer that you can save to be permanent later, or you can click on that to go to your file extension and save a permanent centroid layer. So we can run that. One thing to note with the centroid tool in QGIS is that it doesn't automatically put the centroid inside the polygon. It's more the center of gravity of the polygon itself. So we can see in this example that the centroid is actually put outside of the polygon. So for this exercise, I moved those that were outside to the inside for our usage. So I'll just turn that back off, and this is the centroid layer that I provide. The next factor, now that we have these points, is, as I said, there's a start point and end points to put into the tool. So we need to first define where we want our start point at. So we have our centroid layer. For this exercise, I focus just kind of on the center of where we're at in the Proklitija National Park in southern Montenegro. And so I selected that point and extracted it and created an individual start point. So if we look at the attribute table for that, it now just has a 0 ID, but it's maintained the WDPA ID, the area and the country, in its attributes. Then for simplicity's sake, I didn't use all the centroids. I don't think the tool would actually work if you tried to do all of these connections at once. And so I selected a subset that were greater than 125 square kilometers and in the area. And so for this exercise, these other red stars are the focus that the least cost path are going to be calculated starting from the start point and then going to each one of these endpoints. And then the final and one of the most important aspect of these analyses is the resistance raster. So for this, we are using a resistance raster I created that's for large predators. That is a combination of their habitat suitability, the inverse of it, so areas that are very good habitat suitability have low resistance. So, they're the model's most likely to go through those lower resistance areas. And then also within it is also a combination of energy resistance. So areas that are a lot of topographical relief, so really high steep slopes, have a lot more resistance as well. So animals not able to climb cliffs that easy or avoid those types of areas. So once again, these dark blues are low resistance, starting at about a value of 82. It's a relatively arbitrary scale, but I put resistance rasters from 1 to 1,000. And then 1,000, so you can see some of the highways, some of the urban areas being the highest resistance to potential movement. And this is a buffer that we don't need to worry about for this exercise. So I'll turn that off just so we can reorient for where we're at. So now we're ready to run this analysis. So we can go up and search for least cost path. Now, since we installed the plugin, it automatically added this cost distance analysis to our toolbox, and it just has this one tool, least cost path. So we can double click on least cost path, and then the cost raster layer is this resistance layer that we just created, or we just talked about. And it just has one band. It should automatically populate. We have the start point in southern Montenegro. That's conveniently labeled start points. And then the endpoints, that's our selection of about 22 endpoints across Central Balkans. This also has the option of only connecting with the nearest endpoints. So if you just want to get at the one that's closest or a few that are the closest. And that's pretty much all you need to run this tool. Once again, we can either create a temporary layer or click on this to find the file path you want, where you want to save a permanent layer. So we can run this and complete it rather quickly on the server that I'm running this on. And it's closed. And so you might be able to see these faint lines now that were automatically generated rather quickly. And we can start to talk about what these different patterns are kind of showing us. So obviously they all started at the start point. 1 second. To make it kind of appear better, we can go into the symbology, and this effect neon is usually very nice for showing these rather quickly. I made a slightly different one, so we'll switch to this blue. So you can see these rather jagged lines that are least cost path. If we were to take a few lessons from these, first of all, it's important to realize that the centroid will influence to a point, to a degree, where the corridor is likely to be modeled to. So obviously, if this endpoint was over here or over here within this one protected area, the path would be slightly different or significantly different if it was in this northern region. So it's important to either put this point in an area of good habitat or a place you really want to connect, or something that makes intuitive sense for creating the corridor. So the path itself, each one is trying to follow the least accumulative cost as it moves from point A to point B. So if we were to look at this path, which is actually an accumulation of 4 different paths, we can turn back on this resistance raster and see why this path was followed this way. So once again, the resistance is higher resistance to less suitable habitat and areas of high energy expenditure by the animal. So this is where having different base maps is nice. So we can see that these dark red areas are areas of high resistance, either due to human modification or energy in this case. And then there's a light, more of a light yellow area within here. In this case, this is actually a mountain pass surrounded by modification to the northeast by humans and to the southwest by modification, by other forms of human modification as well. So this path is slowly, jaggedly moving through connecting pixels that ultimately make the least cost to get to the point B. What's interesting about this is it diverges slightly from what the actual protected area is at the moment. So you can see that and we can see why maybe just using polygons for just connecting polygon to polygon and not learning what's happening maybe inside the polygon itself, especially with high human use protected areas, may be missing some of the information and data. But then once it's within this protected area portion, it's rather straight line through more of these low resistant areas until it crosses these highways, where maybe an important area to be mindful of for wildlife crossings or providing some sort of wildlife bridge. This is the jaggedness of it is in part because the resolution is only at 1 kilometer. As you're working with these finer and finer scales, it's obviously more important to have finer and finer resolutions. So if this was 100 meter to 30 meter resolution data, the jaggedness would be a little less pronounced with the lines themselves. You can kind of see that over in this, when we're moving to this protected area in Bosnia and Herzegovina, where it's actually a lot more dynamics, where the line actually was moving around this reservoir and between more topographical areas and less topographical human modified areas. So each one of these created its own row in the attribute table, and then it includes the start point ID, which all was from the one start point, and then the endpoint ID from the endpoint feature layer. And then the final is the total cost, so this being the total accumulated cost faced by the animal as it moves across all the pixels combined from point A to point B, from start to end. The last thing that might be helpful to point out is that since it is an individual line, since it is one line going across one pixel width, it can be helpful for display or also for management purposes to create a buffer around the lines. So for this, we'll use the buffer tool, and as an example, use a 3 kilometer buffer width. We'll keep all the same for now, and then just create a temporary layer. So we can see this creates maybe a quick but slightly more realistic corridor, especially for management if you're trying to identify areas that could be turned into other effective conservation measure locations or additional protected areas or some sort of other regulation. This, once again, if we look at the attribute tables, took the same attributes, so it maintains the attributes from the line in which it buffered. Close that. The only other thing that you might want to do is, we can see that these have all these individual rows. If you don't need that, and maybe just for display purposes, we can go back to buffer. Make sure you click on the line again, because it wants to buffer the buffer. Back to 3 kilometers. And then the big change is clicking this dissolve result just to make it all a single feature. And then you can see there's all that overlap doesn't exist anymore, and it all was dissolved into one feature. So this might be more beneficial for displaying. It's just a cleaner looking version. We can bring all that back on top of the buffer, and we can kind of see what our final result is. All right, thank you very much.